Okay, so I think you got the quiz yesterday, right? And I think some people were doing cheating, around 13 or 14 people. So they can meet me, at some point. Okay, so anyway, so so if you want to take help of any open thing, it's better to talk to me. I will allow you with open chat GPT and open Google and try to solve the problem, right? If you think that somebody can help you. Anyway, so we started with complex variable, and I think I gave you some basic ideas about complex plane, and then complex numbers, and also some inequalities, especially that mod of z1 plus z2 is less than or equal to mod of z1 plus mod of z2, the triangle inequality, and couple of other inequalities which are very useful while computing certain things. So first, today I am going to give you a polar coordinate, okay, and about a complex number. I think that also you know. I'll just recall, okay, that z can be represented as r times e raised to power I theta, right? Where r is the argument. I mean, like r is the mod of z, okay, which is square root of x square plus y square, and theta is tan inverse y by x, right? This is very basic definition that you know, but very important. You will see that these ideas are useful when we define functions, exponential function or log function and other things of complex variable, and they behave bit differently as compared to our real part, I mean the real analog, right? So you see that difference is quite a lot, okay? And so after defining this polar coordinate, I am going to talk about functions of complex variables. So I mean, I will not give you examples, but I'll just immediately focus on limit, continuity, and differentiability. The ideas are very simple, just like you have for that epsilon delta definitions for complex variable functions, okay? And so limit is fairly straightforward. So if we say that the limit of a complex variable function f of z, right, z tends to z naught exists if for every epsilon positive, those kind of things, right? Mod of f of z minus L is less than epsilon whenever 0 is less than mod of z minus z naught less than delta, right? The definition you can make automatically, right? Okay, the only thing is that now when we are saying 0 is less than mod of z minus z naught less than delta, we are talking about a disk, right, where the z naught point is omitted, deleted neighborhood, but neighborhood is now a circular disk as compared to real case where it was a open interval, I mean the interval kind of thing, right? So this is a disk, okay? So similarly you can define continuity of a function in a similar manner, okay, and differentiability. But differentiability, there are many more things that are possible that are not possible in classical case of real variables. So we'll talk about those things. And finally, I hope by the end of today's lecture we should be able to introduce what is known as Cauchy-Riemann equations. So if the function is differentiable at a point z is equal to z naught, they satisfy certain equations, and these equations are involving two variable functions, known as component functions of a complex variable function, so which I am going to talk about it, okay? And then what are when there are sufficient conditions and so on, that we'll talk probably about in the next lecture. So this second inequality is very important, as I mentioned. It will be used quite often. Okay, so if we draw this plane, suppose this is a complex number z, this angle is theta, and actually this you can keep on moving also, right? So basically this angle is theta, So you can take some point here, draw this line. So basically you can write down a complex number z is equal to x plus iy, where x is nothing but r cos theta. This distance is r, right? And y is equal to r sin theta. I think this is pretty obvious, right? So, and so we can write down z is equal to r times cos theta plus I times sin theta, which is also of the form e raised to I theta. Right. So theta is an angle where this vector is making with the x-axis. So we know that tan theta is nothing but y by x. So theta is nothing but tan inverse y by x, right? So theta is known as here, and r is what? Mod of z, which is nothing but square root of x square plus y square. So this is a pretty straightforward thing. One thing now, once we have this representation, you can see that that angle is theta, and this term involves cosine and sine functions, and we know that there is no change if we replace theta by theta plus 2n pi, right? 2n pi will not make any change. So basically there are different values, right? So actually this theta, we can find different values. We call it argument of z. So set of all such values, okay? So basically, as there are many values of theta, the first round of circle, right? So first set when n, so basically when n is equal to 0, because we know that cos of theta plus 2n pi is same thing as cos theta. So when n is equal to 0, you will get the principal value, right? So we call it as a principal value of argument of z. Of argument of z is denoted by capital argument of z, right? This. So this is the unique theta. I am just writing it bigger theta, such that minus pi less than theta less than equal to pi. Okay. So as I mentioned, because theta could be different, so I think maybe I should write it down, the argument thing also. I can say that argument of z, I can write down the expression as principal argument of z plus 2n pi, n is equal to 0 plus minus 1 plus minus 2 and so on. So this argument of z happens basically when we have n is equal to 0, basically, or you say that I am just taking one round, right? Say minus pi to pi. Okay. So this is nothing but capital argument of z is the unique theta. This symbol stands for unique capital theta, where theta lies between minus pi to pi. This is so basically when there are several values possible, I am restricting to one round, right? And that one round is from minus pi to pi. I will call it as principal argument. Okay. So principal argument is denoted by this, and so small argument of z, which is all possible values, is principal argument plus 2n pi. Right. Why this 2n pi? Because as I mentioned, cos of 2n pi plus theta is same thing as cos theta. Similarly for the sine, right? So it will have same values, right? Okay. So there are different values possible when we go for this kind of representation. Okay. And I think this also tells you why there is only one infinity in the complex plane, if you can think about that. Anyway, so that is about argument of z. So I think then you can if we take a small example, minus 1 minus I has principal argument minus 3 pi by 4, which lies in third quadrant, you know. Okay, so basically I can say that argument of minus 1 minus I is nothing but minus 3 pi by 4 plus 2n pi. Right. So you can always, if I have to compute principal argument, just restrict the value of theta, right, between certain minus pi to pi, and then you can find out what is the value, right, where does it lie. So this is pretty simple thing. There are certain properties about this, by the way, yeah. So one more thing, if mod of z minus z naught is equal to, if mod of z minus z naught is equal to r, then z is nothing but z naught plus r times e raised to power I theta. Right. This is pretty obvious. This is kind of a circle, right, of radius r, centered, right. Z is a generic point here and z naught is a point here, right. Okay. So certain properties of argument function. First, that argument of z1 into z2, it behaves like a log function. Argument of z1 plus argument of z1 z2. This is very problematic. Argument of z1 z2 is equal to argument of z1 plus argument of z2, and second, argument of z1 by z2 for product of two complex numbers and the division is argument of z1 minus argument of z2, right. So these are the simple formulas to prove. I am not doing any of the proofs here, but actually using this you can calculate if there is a complex number which is bit involving many terms, you can actually separate them up and compute the overall. So I think I will give you as an exercise. Suppose z is equal to minus 2 divided by 1 plus root 3i. This is a complex number, so directly computing argument is difficult. So what you can do, argument of z is equal to argument of minus 2 minus argument of 1 plus root 3i, right. Now this is pi and this is pi by 3. So overall is, so basically I need to find what is pi minus pi by 3, 2 pi by 3, right. Now this lies between minus pi and pi. So basically, in fact, this is the principal argument also, right. So there, in these kind of complicated complex numbers, actually you can use these formulas to compute the argument, right. It's really simple thing. So remember when we restrict theta from minus pi to pi, we get the principal argument, right. Otherwise we have the general value. Okay, so I think, but this you know already from your 12th, right? Argument padha hai? Very nice. So we can talk about functions. So I think we are talking about functions from C to C. C is the field of complex numbers, right? Or complex valued function. So we call it as W of function of Z. Now since Z is x plus Iy, W, which is f of Z, is nothing but u plus iv for some other complex number, for some u and v, right. If Z is x plus Iy, w which is function of z will be another complex number, say u plus iv for some u and v. Okay, fine. In fact, we write it like w as a function of z is nothing but, actually this function is function of two variables. It will be clear to you in a minute why it is that. Sometime we also write it u plus iv is also in the form of polar forms, you know. So when z is equal to r times e raised to power I theta. Okay. So in that case, f of z is nothing but u of r comma theta plus I times v of r comma theta. Okay. So now let us take an example. F of z is equal to mod of z square. This is nothing but x square plus y square plus I times 0. So that means u of xy is x square plus y square and v of xy equal to 0. Right. So this is the polar form, and in general this is the thing. You can see that for any complex number you can get two corresponding functions. These functions are known as component functions of the complex valued function. If w is equal to f of z is a complex valued function, we get two component functions u and v which are functions of two variables. So this is a beautiful connection. Whatever you have seen in terms of functions of two variable, right, limit, continuity, differentiability, those things get slide here, you know, fully, and then you can see what effect they are going to have it, right. Essentially, if we study limit of the function f of z as z tends to z naught, if that exists, then the corresponding limit should exist for the corresponding two variable functions also, right. Those kind of connections are there. I am going to mention that right away. Okay, so once you have the idea of two variable function, I mean this complex valued function, what will be the definition of limit of a function? So we say that the limit of the function f of z as z tends to z naught exists and is equal to value w f of z is equal to w naught, suppose, right. If for every epsilon positive there exists delta positive such that mod of f of z minus w naught is less than epsilon whenever 0 is less than mod of z minus z naught is less than delta, right. Just parallel to the limit of a real variable thing, right, everything is same. The only difference is now this neighborhood is a circular disk, right. Similarly that neighborhood is also a circular disk, right. So we have something like this, that suppose this is a point here, this is z naught, this distance is delta, okay. Suppose somewhere here is z, so z is approaching towards z naught. So z could be on the circle also, I mean the, you know, the circumference also is inside the circle also, right. As soon as this happens, so image of z, so basically I can draw another one, say somewhere here, it could be anywhere, I am just drawing it randomly. Suppose this is w naught, right, and somewhere here is w, and this circle is of radius epsilon, right. So this goes to this. So as long as this means as long as z is in the neighborhood of z naught, as long as z is approaching towards z naught in any manner from any direction, and of course we have, by the condition 0 is less than mod of z minus z naught, means this is deleted neighborhood, z naught is not there, right. This circular disk, whenever z is moving towards z naught in any direction, right, in the neighborhood, because this is delta is a small number, right, image set f of z, which is w, is in the neighborhood of w naught in the circular disk, right. So there the idea of neighborhood was intervals, here the idea is circular disk. That's all. Everything is exactly same. Right? So if I have to show you that, show that this limit exists, you can again do the epsilon delta business. Now only difficulty there, you need to play with inequalities with single variable or two variable. Now you have to play with the complex numbers. That's why I said the inequalities portion is very, very important. Right? You have to use those techniques to show that limit exists. Okay? So let me, ये line फालतू में बन गई है, right? Don't think that this is something. Okay? ये पेन का problem है. This is also not there anyway. So let us take a small example. F of z is equal to I times z by 2. What do you say that limit z tends to 1, f of z will be? Any guess? As z tends towards 1, what is the limit? Huh? I by 2, right? ये तो दिख रहा है ना? इसमें कुछ हाई फाई चीज नहीं है, right? But the thing is that how will you prove it? Okay, so what it says that there is a circular disk here. There is a, you know, z is equal to 1 point is here. This is the whole thing, mod z less than 1. Okay. So basically, when z is approaching towards this point 1, right? This is say z. Right, I have to show that the whole thing is image set lies in the neighborhood, right? So the question is, how do we do this? So we know the definition. For every epsilon positive, there should be delta positive, such that mod of f of z minus I by 2, right? I need to consider this mod of f of z minus I by 2, right? Should be less than delta, should be less than epsilon, right? For some delta, I have to find the value of delta, right? So this quantity I can just compute. This value is mod of Iz by 2. Arey yaar. Iz by 2 minus I by 2, right? I have to find delta. So delta in such that this delta I have to find in terms of epsilon, right? If you remember. Okay. So this delta I have to find such that this is true. Now I started with this inequality. This is nothing but this. Now mod of I is what? 1, right? I is a complex number. Mod of I is 1, right? So the whole thing will be what? Mod of z minus 1 divided by 2. I can simplify this whole thing. Right. Now this thing should be less than epsilon, provided what should happen? I have to find delta. So mod of z minus 1, right? So can I say that this whole thing will be less than epsilon whenever 0 is less than mod of z minus 1 is less than 2 epsilon? It will work, right? So this whole thing will be less than epsilon. The delta should be what? 2 epsilon, right? Then only this will happen, right? So epsilon delta technique, you can show the limit is this. Okay, so this was example that limit exists. What about limit does not exist? Suppose f of z is equal to z divided by z bar. I have to find limit z tends to 0. Does it exist? See, showing that it does not exist because now Z, the generic point in the neighborhood of Z0 should approach towards Z0 in any manner, from any direction, right, in that disk. So I can take two paths, say along x-axis and y-axis. What happens to this limit along x-axis? Y is equal to 0. So this whole thing is what? I can write down f of z is equal to x plus iy divided by x minus iy. Now along x-axis, y is equal to 0. So this whole limit will be what? 1, right? So this f of z will approaches towards 1 along y-axis. Along x-axis, along y-axis this will happen -1. So along two paths, limit is different, so limit does not exist. Right? Just like that, in the two variable case, because see the neighborhood is now different. So in case of single real variable, one has to check left hand limit, right hand limit. And left hand limit, right hand limit should be same, then only the limit exists. In case of two variable function, you know, the generic point x comma y should approach towards x0, y0 from any direction, right? Along x-axis, y-axis, we tried different lines and so on and so forth, you know. Same thing here. Now that it is a circular disk, right? So neighborhood is a circular disk. So z can approach towards z0 from any direction. So I take along x-axis what happens, along y-axis what happens. If both two things are different, limit does not exist, right? So if you are able to find two paths along which the limit is different, limit will not exist. Showing that limit exists, you have to use your beautiful friend epsilon delta, right, to show that limit exists. अब समझ में आ रहा है ना, मैंने epsilon delta पे इतना टाइम फोकस किया, वही एक सब जगह वही है, right? That is really fundamental thing. Okay? Any question? This is okay, clear? Because you need to understand the neighborhood. The idea of neighborhood is different now. That's all. Limit definition is absolutely same. The neighborhood idea is different now. Now the neighborhood is in the form of a circular disk. Okay? So z is approaching towards z0 in that disk from any direction, and image set approaches towards w0, right? In that neighborhood, right? That is the thing. Okay, then we have one fundamental result which I am not going to prove. It requires epsilon delta business. The proof is given in the notes. If you want to read, you can look at it. It's a theorem on limits. Suppose f of z is equal to uxy plus I times vxy. F of z is a complex valued function, so it will be something like this. Suppose z0 is equal to x0 plus I times y0, and obviously w0 is equal to u0 plus I times v0. I mean the corresponding thing there on the other side. Then we say that limit z tends to z0, f of z is w0, if and only if the following double limit exists, that limit uxy xy approaches towards x0 y0 is u0, and limit xy approaches towards x0 y0 of vxy is equal to v0. So this complex valued limit exists if and only if the corresponding two variable limits exist for the component function, right? And this result is if and only if this can be proved using epsilon delta. तो अगर आपको चाय पीने का मन है तो आप बैठ सकते हो लेकर के, राइट? और अगर you know, already it's there in the notes if you want to see how the proof works. So basically you need to remember here the neighborhood is in the form of a circular disk, right? And here also, basically, you need to show the, the distance will be again the equivalent distance, square root of terms, right? If you remember two variable case, all those correspondence you have to establish. Since it is a routine thing, so I am leaving it for you. जो excited लोग होंगे वो calculate कर लेंगे, जो अभी भी struggle कर रहे हैं, but I think some of you are still struggling with the epsilon delta, right? I can see that. It's not difficult, but you need to spend time. जैसे कोई गाना अच्छा नहीं लगता है शुरुआत में, बार बार सुनो तो अच्छा लगने लगता है, राइट? तो बार बार सुनो, बार बार सुनो, राइट? और वो कहावत भी है ना, करत करत अभ्यास जड़मती हो सुजान. So you should look at it, right? Expose yourself enough, you will like it. Anyway, some other results which I will mention again without any proof, although the proof is again given in the notes. It's not so important to look at the things anyway. This limit is infinity if and only if limit z tends to z0 1 over f of z is 0, right? Number 2, limit f of z approaches to infinity is w0 if and only if limit. We can use these results without proofs. Proof can be done with epsilon delta. So you have enough material to take some snacks also today. You will be able to do it, right? Third, limit z tends towards infinity, f of z is equal to infinity if and only if limit z tends towards 0 1 over f of 1 over z 0. So these are equivalent characterization. Limit of a function is infinity, complex valued function if and only if limit of the corresponding inverse 1 over f z should be 0, right? Obvious fact, but can be proved using epsilon delta, right? So I have just mentioned these results. And one can use this quite often while doing certain things, certain calculations in the complex valued function. So you see, so fast, limit हो गया खत्म. हमने एक एग्जांपल किया एक्जिस्टेंस का, एक नॉन एग्जिस्टेंस का, राइट? लिमिट की डेफिनेशन हो गई एप्सिलॉन डेल्टा. कुछ है इसमें ट्रिवियल थिंग, राइट? नाउ वी गो टू मेन इशू है डिफाइनिंग फंक्शंस विच इज ब्यूटीफुल. आई विल टॉक अबाउट इट. ये सब तो आसान काम है. Similarly, now we can start. अभी half an hour हुआ है. We can even finish the continuity business also and the differentiability also, right? Continuity में क्या रहेगा definition में? A function f of z is continuous at a point z is equal to z0 if for every epsilon positive there exists delta positive such that mod of f of z minus f of z0 is less than epsilon whenever mod of z minus z0 is less than delta. हो गया, right? कुछ है? Same definition. एवरीथिंग इज सेम. ओनली थिंग इज अब एक्स की जगह कॉम्प्लेक्स है. तो डिस्क नेबरहुड अलग है, बाकी कुछ एवरीथिंग इज सेम. मूल तत्व है नेबरहुड, राइट? कैसा नेबरहुड यूज कर रहे हैं? आई थिंक सम इन वन ऑफ द क्वेश्चन इन द सैंपल क्वेश्चन पेपर फॉर टू वेरिएबल फंक्शंस यू माइट हैव सीन दैट आई हैव टोल्ड देम if you take the if you change the distance, if you take equivalent distance, neighborhood looks different. If you take the other distance like Manhattan distance for two variable functions, neighborhood will be different. So the idea of neighborhood depends on the distance. So distance is a very, very fundamental thing in mathematics and in engineering, wider applications, the idea of distance. Actually you will see that from these calculus. So basically everything is handling with, so basically neighborhood is a very important thing. It varies depending on what we are doing in which scenario, and neighborhood can be determined by the distance. The idea of distance determines the neighborhood, and distance has been, so this thing has been generalized to what is known as topology. Topology का नाम सुना है? Topology is a beautiful thing actually, you know. So there are different kind of topology, point set topology, algebraic topology. I'll give you one example. What does it mean by topology? वो मेदू वड़ा खाया है ना, or you call it donut. So donut or मेदू वड़ा is equivalent to a coffee cup topologically. क्यों? दोनों में एक छेद है, right? So you can find one-to-one and on-to function which can translate medu vada or donut to coffee mug. Okay, so they are same. So all this idea has been generalized to topology. Beautiful subject, wider applications, right? So I think हमारे यहाँ तो topology का कोई कोर्स है नहीं, बट अगर किसी को इंटरेस्ट हो तो पढ़